All right, welcome back. And now in this example, we look at the given angle and the two sides. So notice that we've got two sides. One of the sides is across from the given angle. So again, this is that potential where we might have one or none, right? So in this case here, again, A, which is across from the largest side, this is an obtuse angle, which means A has to be bigger than B, which it is. So in this case, we know we have one solution. So let's solve for it. Okay, so now, let's set up our law of sines. So we're going to do sine A over A equals sine B over B. And so now I'm just going to plug in the things I know and solve for sine B. And then solve for the angle B. So we get sine of 121.4 degrees over 28.4 centimeters equals sine B over 11.2 centimeters. So now what I'm going to do is I'm going to multiply both sides by 11.2, and so I get sine B is equal to 11.2 times sine of 121.4 degrees divided by 28.4. Okay, now put this in my calculator and I get sine of B is approximately 0.3366. Okay? Now, what you could do is, since we're ultimately going to solve for B, I could just go B, right? I could take the inverse sine of both sides and I can say, okay, not sine. I can say that B is equal to the inverse sine of this whole thing. So I could do 11.2 times sine of 121.4 degrees divided by 28.4. Okay, I could take the inverse sine of this whole thing and just get my angle, right? Or I could just do the inverse sine of this, whichever one you want to do. And I will get where's it at? Oh, there it is. 19.67. So approximately 19.67 degrees. Now, so I can also round this to, let's say, 19.7 degrees. Okay? And notice that we've got three significant digits. So I could have done here, but the book, they go to 19.7 degrees. No big deal. Okay? So 19.7 degrees. Now, at this point, I've got two of my angles. Okay? And so, I can get the third angle easily, right? Because all of the angles have to add up to 180. So if I take 121.4 plus 19.7, that gives me 141.1 degrees, right? Okay, and then I can subtract this from 180. So 180 minus 141.1 gives me what? 38.9 degrees. So that tells me C is equal to 38.9 degrees. Awesome. Now, I can use the rule of, the law of sines again, now involving C, to find the last side, which is C, right? So now I set up my law of sines, so I'm going to go back to sine. Well, in this case, I'm going to do it the flip. I'm going to flip it. So it's going to be A over sine A is equal to C over sine C. That way I can just easily solve for C, which is what I want. So this is going to be 28.4 centimeters over sine of 121.4 degrees equals C over sine of 38.9 degrees. Now I'm going to multiply everything by sine of 38.9 degrees and I get C equals, let me rewrite this, 28.4 times sine of 38.9 degrees divided by sine of 121.4 degrees. And now if I put this in my calculator, I get an approximate value of 20.9 centimeters. So 20.9 centimeters. So I found angle B, and then I used the fact that all three angles must sum up to 180 to find angle C. And then once I found angle C, then I can use the law of sines again to find side C, and I've solved the triangle. Okay, that's it. Have a great day.